Hello and welcome to Education at SSBG, online video tutorials. We were into chapter Sound of class 8th CBSE. In this video, we will see some of the queries asked by the boys and about ultrasound and audible range of humans. Well, there was a question in previous video how to find the frequency of the swings which are in front of you, and one of the student has expressed a difficulty in finding this solution. So what we have to find here is frequency of all the three swings which are in front of you, starting from the first, which is bigger one, right? So let us go and try to find the solution of this, right? I'm talking about the first one now. The rest you can find later, okay? Frequency is number of vibrations or oscillations in 1 second. So in 1 second, how many swings will be there? How many vibrations will be there? So the best method I had suggested you to find out total time for 10 oscillations, 10 swings. And what is one swing? From one extreme position to next and coming back, right? We shall add a clock here and start our experiment, right? Here we go, start. One oscillation over, second over, third over. You can count. You can even watch the clock which is running. It started from 1 minute. Now how many oscillations? 7 oscillations over, 8th one over, 9th one, 10. Right? So how much time taken for 10 oscillation? 60 seconds minus 28 seconds. So 32 seconds taken, right? And what is the frequency? How many oscillations in 1 second? Right? In 32 seconds, 10 oscillation. In 1 second, how many oscillations? You have to calculate yourself. Express that in SI unit. What is SI unit? Hertz is the SI unit. I'm not going to do it here on the screen now. Do it again. Try if possible. Write the answer in the comment box. I'm giving you one more example to find time period and frequency. And what is time period? Time taken for one oscillation is time period. Number of oscillations per second is frequency. I'm going to show you a pendulum, and you have to write in a comment box time period and frequency of the pendulum. Let us start. One oscillation over, two oscillation over. Have an eye on, even on the digital clock. 6 oscillations completed. 7th one, you need to find time required for 10 oscillations. And here it is, stop. So we have 22 seconds for 10 oscillations. 22 seconds, 10 oscillations, and therefore 1 second will give you a frequency of this pendulum. And once you find the frequency, it is very easy to find the time period. Can you do that? Well, try this. We know that vibration is required to produce sound, isn't it? We have seen vibrations in pendulum. We have studied vibrations in air columns to show that how sound travels from one end to another end. But can we hear sound from all vibrating bodies? No, not at all. For example, the pendulum or the swings which you have seen, they vibrate, but we have not heard any sound when they are vibrating. Water waves on the small scale, they vibrate, but we don't hear sound, right? But sound from the musical instrument we hear. Sound from the drums we hear. It is because our ear can hear within the frequency of 20 hertz to 20,000 hertz. That is our audible range. That means we hear all those sound frequencies which are above 20 hertz and below 20,000 hertz. But some animals can hear sound of frequencies higher than 20,000 hertz. For example, dogs. Dogs have this ability. The sound which we cannot hear, the dogs can hear. Frequency of 20,000 hertz are referred as ultrasound. And the frequency below 20 hertz are called as infrasound. Ultrasound technology is used in medical science. In hospitals, high frequency waves are used to understand abnormality of organs inside our body. Bats use a variety of ultrasonic ranging techniques to detect their prey. They can detect frequencies beyond 100 kilohertz, possibly up to 200 kilohertz. I repeat, 100 kilohertz to 200 kilohertz. We human beings can only hear within 20 hertz to 20 kilohertz, that is 20,000 hertz. Now we'll take one more concept, and that is characteristics of sound, right? One of the characteristics is loudness. You all have studied that vibration is required to produce sound. In the previous video tutorial, you have seen how a vibration can be represented in a graph in the form of diagram, or we can call it as a wave, right? Now when you can draw again a vibration into a diagram, it will be in terms of crest and then trough. Look at the picture here right on the screen. It started with initial position, goes to one end and then coming down and goes back to initial position. And this is what is one wave. And it continues then, goes to another extreme position, gets back into initial position and down extreme position and then coming back and so on. So the entire representation of a vibration is right now in front of you. The upper portion, the highest point of the wave, which is there in positive y-axis, is called as crest. So all those highest points are to be denoted as crest. And the lowest part of the wave is called trough. Now the point where it started from initial position and then goes to crest and trough and coming back to its initial position, which is now represented there with the arrow mark, is referred as one wave. And it is equal to from one trough to another trough, consecutive trough, or from one crest to next consecutive crest. This can also be called as one wave. Length of the one wave is called wavelength. So till now you have studied how to represent crest and trough, one wave and wavelength in the diagram of wave. Suppose a question is asked to draw the diagram, like draw a wave of sound and mark the following. And what are those to be marked? Crest, trough, and amplitude. You can very well mark crest, trough, and even the wavelength you have studied already. But what about amplitude? Now we shall see now the meaning of amplitude. When the medium vibrates, or let us say it goes to and fro, at one point it goes to a highest displacement, maximum displacement, right? And that is the displacement we call it as crest or trough. That is the maximum displacement. Now how much is displaced from its initial position? I'll show that by using arrow mark. This much is displaced, right? Or below, we can say that from initial position this much of displacement has taken place in the medium. You can even take in the next wave also. And that is the maximum displacement of a medium. And maximum displacement of a medium is called amplitude. And why is amplitude more important for us? Because as the amplitude is more, the sound is very loud. Loudness of the sound depends on amplitude. That's why higher the amplitude of wave, higher the sound. Let me give you an example of, let's say, a wave A and then wave B, right? You can compare the amplitude of these two waves and tell me which will be louder. As I said, loudness is depend on the amplitude, and what is amplitude? Maximum displacement. In the wave A, displacement is less. You see the height of the wave there. Whereas comparatively, in wave B, displacement is more. So in the wave B, amplitude is more, and that's why B is loud. Loudness is measured in decibels. Do you know when we whisper, the sound is of 10 decibel, just 10 decibel. When we whisper, the sound is of loudness 10 decibel. If you talk casually, it is around 30 to 40 decibel. Moving car will be around 70 decibels. A fast motorcycle can go up to 90 to 100 decibels. And the jet plane will be around 100 to 150 decibels. And when loudness is more, then it can damage our ear also. When we breathe, it's a very low sound. It is around less than 10 decibels. Now look at when you are in a traffic, heavy traffic, it will be around 70 decibels. It will be too much of annoying. In the factory, it will be 80 decibels. So if it goes 150 and above, and you stay there for 25 minutes, it is said that our eardrum rupture. Do you know when the DJ music is played, the sound loudness will be around more than 100 decibels. In such music, just think of a baby whose eardrum is very sensitive. It is a disaster to keep the baby near a heavy sound for more time. World Health Organization has depicted a pyramid of health effects, right? It says that health effects of noise. And what is noise? Anything which is unpleasant. Anything means the sound which is unpleasant is a noise. Sometimes it can be loud, it may not be loud. But if it is unpleasant, we can call it as noise. So what happens? It disturbs us. We get annoyed. And what is the side effect of getting disturbed and annoyed? We don't get sleep properly. Right? When somebody shouts nearby us, you suddenly get diverted from your attention. More of such disturbances will have a sleeping problem. You develop stress, more of risk factor, blood pressure, cholesterol, right? And what do you mean by stress? Stress is one's response of any kind of demand or a threat. If you are very much afraid of something, then you are under stress. And what happens when you are under stress? Your blood pressure goes high. Heart has to pump with more force. The blood may not reach properly to your organs. And finally, if this noise level continues to be for many years, then it ends up in some diseases which may result into a death. Well, we shall conclude here. See you in the next video tutorial. Thank you very much.